the formula. What is the molar capacity formula? C is equal to CV plus PdV by RdT. Okay, I'll make you to recollect. So what is the molar capacity? C is equal to dq by dt. dq you write du plus dw by dt. du by dt plus dw by dt. This will be CV. One more we are taking it, dw. So this will be pdv and this is dt. So what all you should calculate from the information? Gas bubble, he has given constant pressure is Cp is telling. So we can further write, and we know Cp minus Cv equal to R. So Cv, what you can write? Cp minus R. Okay, no, that P dV dt has to be determined from the information given. He has given surface tension sigma, radius R, pressure P naught outside the bubble. I think that much of information. So what do we have is, we have a bubble. Soap solution is here. Okay, this is the air inside which will undergo the thermodynamic process. You have to focus more on the air inside. We are not bothered much about surface tension. This is the air. Oh, yeah. This will undergo gas inside bubble. Okay, saying gas. Yeah. Now what we are going to do is we are going to supply heat, slowly supply to a bubble of radius R. Okay, how we supply, let's not bother. It will somehow what happen, the gas inside the soap solution will permit. It will permit the heat to pass through it and will be absorbed by the gas, and the gas will expand. And the gas in fact will expand here. So now there'll be a pressure force will be acting. So why I'm bringing all this, because like I had to generate an idea. So I had to think in this way here. So here the gas inside it will be exerting a force in this direction, and the air which is outside will be exerting, and it's in equilibrium. So when I supply heat, what will happen to the pressure of a gas will increase. What process the gas will undergo? There's a very difficult thing which we have to resolve. If you can answer this, if you can analyze this, we can proceed very easily for the problem. We have a habit of whenever surface tension comes, we directly take isothermal, no, for granted. Am I right? Shall I say isothermal process? Isothermal process means what? No change in temperature. If there's no change in temperature, infinite. Shall we put answer infinity? We took it for granted. Huh? You see all the surface tension problems. Whenever anything is there, no, we select temperature constant, isothermal process. So I may give, if I'm a paper setter, I may give this option infinity, and maximum will pick up that, and teachers also will pick up that. But there's no rule. That's what I'm telling this one. There's no rule. You look at all the books what we have in our Indian textbooks, no. Whenever surface tension and if any process it undergo, if any air enclosed, no, we'll take it to be isothermal, and it's need not. Slowly is telling, even if it's slowly, also it need not be isothermal process. I think you have a very famous question. Huh? There's a bubble, there's an air bubble inside in the lake. As it rises up, when it reaches the top of the lake, surface of the lake, find the change, find the radius of that one. There we are going to take that as the isothermal process. Okay, put it. Okay, this is something very important. You see that one. The bubble will be here, having a radius r1. By the time it reaches surface, its radius will decrease or will increase. Anybody? This is the air. This is the water. Yeah. What will happen? Radius will increase or decrease as the air bubble rises up. Where pressure will be more here, no? Pressure at a depth. So here you write it P1. I think everyone knows this problem. Or shall I explain? Radius of the bubble will increase or decrease. That's what I'm asking you. Increases, no? Okay, good. Okay, there I'll do one thing. Yeah. R1 and this is R2. Two answers are there, increases and decreases. What shall I do? Say we'll do one thing. Pressure here will be more, no? Should be increases, no? It should be increases. Pressure here more, here is less. So how you write pressure inside here? P1 equal to P plus 40 R1. Here what is the pressure here? P2 equal to here some pressure P dash P naught plus 40 R2. So pressure here is more, here is less. If pressure decreases, volume should increase, so it will increase here. And now what is the process we'll assume? We'll assume the air to undergo isothermal process. We have took it for granted, but there are, if you look at the some good books, no, if this rises, it all depends upon temperature of water. If this rises, because in summer, the same thing. In summer, what happens? Due to higher temperature, the viscosity will decrease. This will rise rapidly. With high speed, it will move up. Then the process will undergo rapidly or so like a very fast. Then we know if a compression or if a compression or expansion if it occurs very fast, then what happens? It will be adiabatic. If during winter season the temperature of water will be less and the viscosity will be more, viscosity of water will be more, the air bubble rises gradually. Then a gradual expansion of air will take place, and because of that, what will happen? It will be isothermal. Very important. I hardly seen anything in our books, but this what they tell, like, so when to take that adiabatic or like a isothermal, it all depends upon the environmental condition. That's what we have here. Okay, clear this one. So the season, it all depends on season. So at higher temperature, the viscosity will be less. The air bubble will rush. So the expansion occurs rapidly, adiabatic. In the winter season, maybe at lower temperature, viscosity will be more. The air bubble will gradually will move up. Then it will undergo isothermal process. Okay, fine. But if you look at the same question in exam, if they ask you, you have to ask question yourself like, what are the environmental situation? Otherwise, by default, we'll take it isothermal. If this rushes with high speed because of less viscous force, no, then it should be adiabatic. I'm making clear. So in IIT's JEE Advanced, they may trouble you with this data. The temperature of water will determine what process the air will undergo. Okay, let's come for this one. So I cannot just write infinity, here. It will be isothermal. It is given this one. So can we take it to be isobaric process? Pressure will change, volume changes. It cannot be isobar, isochoric, cannot be isothermal. So what is the next left over? Can it be adiabatic? I too don't know. So let it be general thermodynamic process because I'm not sure. If I mentioned anything, okay, go for it. Otherwise, we should go for general thermodynamic process. So the gas here, we are not very sure what process. So gas undergo GTP. Okay, let's get into this one. So PV equal to nRT. I'll take it out. This one. So this will be P dV plus V dP nr dt. What is the volume? 4 by 3 pi r cube, smaller I took. So dV will be 4 by 3 pi 3r square dr. This is a thing. Okay, what is the pressure? P equal to P naught plus 4 st by r. Atmosphere, no? So dP is equal to 4. P naught will be constant. Atmosphere pressure will not change when you supply it to the gas. So I'll replace all the terms here. P, what is in place of P in this equation? This is very important. P is dV is 4 by 3 pi 3r square dr. V, dP is nr dt. Okay, substituting nr dt. Now number of moles, I'll make it 1. Everywhere we made it. Okay, substitute dt value there and substitute again P dV once again here. So I have, let me write all 1 dV 2 3 and this is the equation. Put 1 2 and 3 in A. Cp minus R. Okay, P value. dV value. Where is the dV? 4 by 3 pi. So this will be dr. So minus 4 V st r square dr. By r, no? All divided by r. And then we have to solve this one. Then we'll get expression. So shall I write directly? Solving above Cp there's a book answer you have to verify. This much is what the answer that is there in the book. Okay, I think be careful about this condition. I thought first isothermal, then I went for infinity, then adiabatic process, then in adiabatic process we know work done. So these are some very random because they are not said anything, no. So you can't take it to be that process only. So gas undergo adiabatic process. It's a general thermodynamic process. I think this idea is very important. Please do revise. I think we do have questions of these possibility of asking because it's only in Pathfinder. I think these questions are there. What all I just picked up previous one. Possibility of asking in advance, especially surface tension. Always is coming with a very creative question. And till now they didn't touch ideas of like this possibility of asking because they asked only related to surface tension. They never asked surface tension mixed with other idea till date. You check the advanced paper. So possibility of asking. So surface tension with elasticity, surface tension with electrostatics, surface tension with air, thermodynamics, surface tension previous problem with viscosity, surface tension with gravitation also it may bring. So this thing, so one question will be there always, sufficiency, and it's a more creative than even rotation mechanics. You can check it. So if you really want it, accept as a challenge, no, I think you should explore. Okay, we'll stop it. Tomorrow I'll continue from here. Few more
Sir,
good problems I picked up.
in the denominator, P naught plus 4st bar, it should not be multiplied only first term, no sir. You multiply it with two terms. Denominator, sir, in the
Okay,
expression.
this is okay. This now okay. I think that bracket I forgot. Okay, no.
Yes, sir.
Yeah, let me see.